Laboratory Information System, also known as an LIS. So, Laboratory Information Management System is an LIMS, and it manages sample-focused information to provide timely, accurate data to clinicians. It integrates automation and data handling for consistent methods and improved productivity. Then we have our Laboratory Information System, which is our LIS, and this delivers lab data via integrated computers and databases. These features include QC storage, analyzer interfaces, regulatory compliance tools, data sharing, automated reporting, and decision support logic. Just as a note, LIMS and LIS functions have increasingly overlapped, and their functionality is getting to be very, very similar. All right, so input devices. So we have monitors and touchscreens, which I'm sure you all are very well aware of. We also have barcodes. So we have 1D barcodes, which are linear lines read by laser scanners, and 2D, which are scannable in all directions. We also have radio frequency identification, or RFID, and that uses tags to store and retrieve data automatically. Output devices such as monitors, printers, and instrument displays. And then we also have data storage devices, which I'm sure you guys are aware of, but we're going to say it anyway, like hard drives, cloud storage, optical discs like CDs or DVDs, and solid state drives. We have software as well, which has encoded instructions for your computer operation. We have middleware, so that's software that links other software components or applications. So some of you may have different types of middleware depending on where you are working. Laboratory information systems, so user interaction. Personal computers will act as workstations that are connected to the LIS server. Information exchange between user and computer is called interfacing. Workstations are linked via routers, forming a local area network, or a LAN or an LAN, assessing LIS or hospital information systems. A well-designed hospital information system and LIS database improves record keeping, patient care, budgeting, and operations. Interface specs should define data transfer details, timing, destination, and security or encryption. And then we also have a wide area network, or WAN, which connects multiple sites into one network. So general functions of a lab information system, we have patient identification and demographics, test ordering and specimen collection, specimen analysis and test results, and then test interpretation. So for the pre-analytical functions, it's going to manage patient demographics and the test orders. For your analytical functions, it's going to handle that data, that molecular genetic data. It's also going to have auto verification, so automated processing of certain lab results without the need of manual review. And then post-analytical functions, so that's where it's going to generate your lab reports, and that's also managing those critical patient results as well. Overview of automation. So benefits, obviously, it's a reduction of medical errors. It's better than someone's handwriting and trying to figure out what it said. Reduce specimen sample volume. It can increase accuracy and precision. It can also improve safety for laboratory staff. Faster turnaround time of results, because back in the olden days, you had paper that you had to either fax up to the floor or walk up to the floor, have you. Now it just automatically goes right into their inbox electronically. And then partially alleviating the impending shortage of skilled laboratory staff. So hopefully, we won't run into huge staffing shortages. But if we do, we have a little bit of alleviation with having computers in the lab and integrated within the hospital systems. The process of automation. So automated systems typically are going to include a device for sampling patient system or specimens and controls. There's going to be a mechanism to mix specimens with reagents in the correct order. Incubation modules for specific reactions. It can also have a measuring device such as a photometric technology that helps to quantify reactions, and recording systems to capture and store those final results. Steps in the automated analysis. So automated laboratory analyzers are designed to replicate manual laboratory techniques. but they also do it while improving speed, accuracy, and consistency. So the major steps involved include specimen collection and processing. So these specimens are collected and prepared for analysis. This may involve centrifugation, mixing, or other preparatory steps to ensure samples are ready for testing. Then we have specimen reagent measurement and delivery. It will deliver precise volumes of the patient specimen, and necessary reagents are measured automatically and then delivered in the correct sequence to the reaction vessels or cuvettes. And then we have chemical reaction phase. So the specimen and reagents interact during a controlled chemical reaction. Oftentimes it's in an incubated module where temperatures and timing are carefully regulated. And then we have the measurement phase. So the system measures the reaction using specialized detection methods such as photometry, fluorometry, or electrochemical sensors to quantify the analyte of interest. And then we have signal processing and data handling. The detected signals are converted into readable data, and this involves amplification, filtering, and processing to ensure accurate interpretation. The results are then recorded and may be transmitted automatically to the lab information system for review and reporting by us. Automated analyzers. So automated instruments are designed primarily for the most frequently ordered tests. Versatility and flexibility are as important as high volume and speed, so automation is also valuable for less commonly ordered tests as well. Initially, automation was introduced in high volume areas like clinical chemistry and hematology, but today automation and semi-automation extend to the other departments as well, such as urinalysis, blood bank, and micro. Detailed information on automation specific to each clinical specialty will be covered, and it says in clinical chapters, but in your differing courses such as chemistry or hematology as well.